In today's video, I'm going to show you how to make a DIY dew heater. And this is a dew heater strip on my Maxitop Newtonian. And as you can see, it's got a front corrector plate. And like Schmidt Cassegrains, the Mac Newtonians are all susceptible to dew right up front. And I don't have a dew shield yet. And so the first night I took it out, I got dew on the front lens very quickly. It's in the middle of winter, it's real humid. And so here's the DIY dew heater that I made. And I'll show you how to make it and the concept behind it. Here's a commercial dew heater, dew strip, and this one is made for a small refractor. And basically it has a 12-volt power supply and then a variable input. And I like these a lot, they work great. I just didn't have one for my big old 8-inch Maxitop. So anyway, I wanted to do something quick, but the way they work is that there's some sort of resistance wire in this, and it's the same thing as like a seed mat heater or a coil on a stove or something like that. So basically, if you pass a current through some sort of a resistor, it's going to warm up and dissipate heat. And so I got to thinking, well, I had these tiny little quarter-watt resistors. I was wondering if I could make something work with that, at least for temporary. And so I did, and I'll show you the calculations next. All right, now let me explain how this works. So here we have Ohm's law that V equals IR. Now we have power is equal to the voltage times the current. So if we substitute Ohm's law in here, we can see that the power is equal to I squared times resistance. So what I'm trying to do here is saying that what would be the resistance required if I knew the power and the current. So you could say that that's power divided by I squared. So if we know the current, then we can calculate the resistance. So basically here we have let's say we have 3 watts. That would mean approximately 52 ohms. 4 watts would be about 39 and 5 watts would be about 31. So what we need to do is we need to design a circuit such that we have an equivalent resistance somewhere between 30 and 40 ohms. Now, we also have to bear in mind the power limit of the resistors. I have tiny little resistors that are mainly used for just low power applications, and so they're only rated at a quarter watt each. So I had a problem. Initially, I tried to, see, well, what would work to just have one in series or something like this. And the total watts exceeded the value of my resistors by a factor of 4. And so I thought I'd try it in parallel, and then I realized that if I just did 3 strings, then I could have a fairly low ohm rating and then split that power among all the resistors. So the design I came up with was just based on the resistors that I had. These are the actual measurements, 131, 115, and 108 ohms per string, which resulted in 39 equivalent ohms. And so that up here works out to be about 4 watts. And then we say, well, I had a total of 18 resistors and 4 watts. That's around 0.22 watts per resistor, which is pretty near the maximum. But I can easily reduce that current with the ASI error to say 70-80%, and I will be within the wattage limit of the resistor. So if I were to do this all over again, I would just buy higher wattage resistors, but I wanted to do some imaging and I wanted something would work, and I didn't have any 1 watt resistors. I only had 1/4 watt resistors. So it's sort of like being in college when they say, well, here's a bucket of parts. Make it work with what you've got. You don't have time to order from Amazon. And so this is what I did, and I'll show you how I built it. I just need to make one disclaimer, and then this project is for educational purposes only, and if you're going to build this, build it at your own risk. I'm showing you how I built my project for educational purposes, and when you're dealing with resistive heating, you have to be careful. All right, from this tape here to this tape right here is 30 inches. and that is approximately here on the telescope. So I'm going to do 3 strings of resistors, and so I've got the first string set up. These are 18 ohms each, and those are 6 in series. And I have another batch of 18, and then I have some 15 ohms. So I'm going to do these 3 in series, and then we'll tie all the positives together, all the negatives together, and then I'll have to run a return wire. So I've got these pieces of tape that gives me approximately the location of the resistors. They don't have to be exact. I'm going to wrap each one of these in electrical tape so we don't get any shorts. But they do need to be somewhat spaced evenly. It's not hypercritical exactly where they go, but they need to be fairly consistent. I ran into a lot of issues. So now I found the best way to do this is to go like this. See, some of these wires are not quite right and it doesn't look good, and also it's hard to wrap them. But if you wrap it, keep the resistor long, don't bend the resistor wire. And do the same for the other one. Then when it comes time to wrap them and put them together, you have a flat package with no wires that are poking. So when I run into issues like this, I'll just go ahead and solder them. So it's helpful to use a piece of tape to hold it down because I never have any help. Okay, now that's how it's supposed to be. So that's a good solder joint there, and I probably could have done better there if I would have used the tape to begin with. But what that'll do, when you go to wrap this, you're not going to have any wires sticking out, and then to prevent them from shorting, we're going to have to use electrical tape to completely isolate this one from that one. But live and learn. And then we'll do the next one over here. So I think the easier way to do this is to get a piece of tape and kind of hold that down. So it's kind of like a helping hand. And then we're going to grab the last 18 ohm resistor of this pack. And then it's really easier to solder it now. Okay, that's a good one there. All right, so what I've done here is I've wrapped all the electrical connections like this, and I left the resistor exposed just because I'm trying to dissipate heat. And so there's a typical one. And so now we can, I'm gonna do this for all 3, and then we'll measure the resistance for all 3, and then we'll put them in parallel. So I'll do that next. Okay, I am done with the wrapping. So I have 3 strings basically, and here's what they look like. And they're wrapped, and so let's measure them one at a time, and then we'll put them in parallel, and we'll get the total equivalent. All right, so we'll do the first one. Can you see the meter? We'll put the meter here. All right, string number 1, 131.9. String number 2, 115.8. String number 3, 108.2. And now let's put them in parallel. for the first test, I'll just wrap one end together here, and then we'll go and we'll wrap the other one together. And this should be something in the 35 to 45 ohms. The reason it's hard to calculate is because all resistors have a tolerance. And so let's measure that. My design was about 35 and I've got 40.1. So that's right at pretty near where I designed. So let me wrap them up into a package and then I'll come back and show you. All right, so I've got the center here because I want it nice and even. And then I need to be able to use this as like a package. So what I'm going to do is tie them together and get all the slack out as a group. Okay, and now I can go from either end, and then when I wrap it around the telescope, it'll be nice and even. And what I'm trying not to do is I'm trying not to wrap any resistors because I would like them, if at possible, to touch the metal on the telescope to transfer as much heat as possible to the metal. And then I'll do one more here on this end. And then we'll explain what I'm going to do next. What I want this to do is I need to... One end will be all the positives, and then I need to make a return wire for the ground. And it doesn't matter which is which, so I'm not even going to bother to do different colors because resistors do not care which direction the current is in. So now we have basically a strip. And so we'll just call one end positive, and then I will take a wire and just go ahead and wrap it back this way. Or I could go in a circle, but it would be cleaner to wrap it back this way. And then you have a positive and negative here. And then I'm going to use my plug. Where is my plug? Oh, it's in my pocket. And then so that you have just one on one end, and then the loop comes back. So one will be positive and the other will be negative. And I'll do that on the next section. All right, so here's one end. So let's strip this wire. And I don't have to have two colored wires, but for the sake of this video, I'm going, because it's easier to follow the logic, I'll go ahead and make one of them red. And so go ahead and twist those together. Let me fire up my okay, so that is soldered. Now the reason I leave it in this direction is because I'm actually going to go back the full length like this. All right. And then terminate it right here. And so when I connect it to my connection, this will be positive and this one negative. So what I need to do before I snip this is I need to make sure this can reach my ASI air. So, because if I need to make an extension, then I'll probably have to make an extension on the negative. So I will do that off camera and then show you the end result. All right, I'm in the ASI air, and if we go up and we take a look here, pin number 2, I've turned this on. Let's turn it on. Currently we're at 3.2 watts. And you can see our power jumps up to 7.1. Now 8. So it varies a little bit. It's about 4 or 5 watts. And I have tested it. I will now turn off the screen share and I will show you the do strip. Now here is pin number 2. You can see, well, I don't know if you can or not. And pin number 2 there, got 1 and 2. Number 2 is set to do heater. So here's our cable. And it's running around, and boy, I can feel that. Oh, that is getting nice and warm. And we only need to come up just enough to prevent dew. But I've got a little thermometer here. It's been running for about a minute. And let's see if we can get a temperature. So that's about it, so it went up to about 80 there, 81, and then you go up to the right, you can see we got a 10-degree difference. If you get it just right, that laser. So anyway, let me hook this up with the neoprene. I went down to the thrift store and I got this, I don't know what it is, weightlifting belt or something, but it's made of neoprene. And this would be a great insulator to put on the outside. It even has a Velcro strip. So the dovetail ring, the ASI air will mount down here. Can I see that? Yeah. So what I want to do is I want to have it wrapped around something like this. What I want to do before I wrap it up permanently, I want to test it to make sure it'll work. Tape that off. So that should reach the ASI air easily. Okay. And now, for my $3, whatever this thing is, I think it's a weight belt, but I don't know. It's cheap. It is dusk. And I've got my neoprene wrapped around my dew shield, plugged into the ASI air port number 2. And I went ahead and took the lens cap off, and we're getting everything fired up. So what I need to do is wait for about an hour, let this cool down. And the pretty cloudy, and it's humid as all get out. So let's see how this performs. All right, so I've been running for about 3 hours, and there's absolutely no dew whatsoever, and it has worked really well. So by this time on last night, actually I only got about 1 shot in last night before it completely dewed over. And here's an image of the dew without the dew heater last night. Like I said, I only got about 1 shot, and I thought it was clouds coming in, but the entire front lens was nothing but dew. And you can see it's about 50, and the humidity's quite high. So I'm really happy with this. What I need to do is maybe make a better way of attaching this. Currently, just use a piece of tape to hold that neoprene. But anyway, this has been a success, and I'm glad I did it. I saved it about $75, something like that.